name's Gabby Bailato. I'm a Solutions Marketing Engineer here at Keysight Technologies. Today we are going to capture a pulsed radar signal and use scatter plots to do statistical analysis. We will capture things like pulse repetition interval and pulse width and look at how they vary over time. Let's get started. Here's our signal under test, which is centered at 4 GHz. In the time domain view, you can see that there are many different pulse widths. Down in the pulse table, we can see that there's linear frequency modulation on this signal, and you can also see that there are varying PRIs from pulse to pulse. Let's change now to the scatter plot mode so we can understand these pulse parameters trends. There are many different pulse parameters which we can view in the scatter plots. We'll look at pulse number versus PRI and pulse number versus pulse width. This will allow us to view these pulse parameters trends over time. Notice that the PRI increases and decreases from pulse to pulse, where the pulse width is also increasing and decreasing, but not as frequently. Currently, we are capturing about 30 pulses with gated acquisition. It allows us to only capture the on time of the pulses without wasting memory on the dead time. Let's go ahead and increase our pulse count to about 100 so we can view more of our signal. This reveals that the pulse width has a similar trend to the PRI as it increases and decreases, but it only changes about every 10 pulses rather than from pulse to pulse. Now that we understand the pattern of the PRI and pulse width, let's switch gears now to the modulation on the pulses. If you recall from the pulse table, each pulse had a linear FM chirp on it. We can use the scatter plots to select pulses and zoom in on them individually. For this pulse at 2 microseconds, we can see the trend of the frequency is decreasing over time. Next, we can look at the pulses with a 3 microsecond pulse width. We can now see that the frequency is increasing over the length of the pulse. It's decreasing again at 2 microseconds and increasing again at 1 microsecond. So as the pulse width changes, we are also seeing a change in the frequency modulation. We can verify this by selecting pulses that happen to be between the pulse width transition time. You can see now that between pulse 59 and 60, the pulse width has increased, and down below correlated in the frequency plot, we can see that the frequency has gone from decreasing to increasing. In addition to scatter plots, time domain views, and frequency trend lines, there are many other ways to view the captured data. Histograms will allow us to understand the distribution of our pulse parameters. And we can also look at current and cumulative statistics on the signal as well. All of these tools can help with data analysis on your most complex signals using Keysight's UXA signal analyzer and pulse analysis application. For more information, please visit keysight.com or contact your local Keysight representative. Thanks for listening.